Good evening, everyone. We're going to go ahead and get started. Welcome to the Nashville Music Programmers Meet-up. We're a gathering of people from the Middle Tennessee area interested in things related to music and audio and computer programming and coding and digital signal processing, creating software, creating apps. What we're going to talk about tonight is creating audio plugins, a very common tool that people use, musicians will use in the recording studio. I know that there's a wide range of people here coming maybe for the first time or people that come every single time. We get together once a month, usually here at Belmont, but sometimes other places too. And we'll have time to hang out, eat some food, chat, network, and then we'll have a tech talk. I'm the person that usually organizes it, and then someone else gives the talk. But this month, I couldn't track anybody down, so I'm giving the talk this month. But feel free. I'm not sure how much pizza we have left at this point. Are we out of pizza? Sorry about that. I didn't expect half of 1380 students were going to show up tonight, but I'm really glad you all are here. This might be the first time you've ever come across the idea of someone has to make the software that you use. Maybe you've used something like GarageBand or Pro Tools or an app on your phone. Believe it or not, there's an audio engineer whose job is to create that app or to create that plugin or to create that GarageBand software that you're going to use. And can be a fun and creative thing in its own right. It's different than making music, but there are also some things about it where you can, develop something that is completely new and unique, and that can be a cool process too. So I hope that you get an idea about what that can sort of be like tonight. I'm going to be talking about specifically creating audio plugins using something called MATLAB. A lot of the information that I'm going to be going through tonight, I've taken and kind of put my own tweak on it. This is from a white paper by a few engineers that work at a company called MathWorks. MathWorks is a company that makes a commercial software, computer programming language, and what's called an integrated development environment, a place where you can write your computer code. Computer code is instructions that you give to a computer to do a task. What we like to be able to do is tell our computer to be an audio plugin and to take a signal and do something with it, change its sound, distort it, or add an equalizer to it, and lots of those kinds of things. So I'm going to be working back and forth between some of the different pieces of software on my computer. For those of you that might be interested in where is this all coming from, you can track down this paper online and see some of the examples that I'm going to be going through from here too. So what is an audio plugin? What is this all about? What are we going to be trying to do? So this is a digital audio workstation. This is one called Reaper. If you're familiar with Reaper, that's great. If not, it's a lot like GarageBand. It's a lot like Pro Tools. It's just software that people use to record. And once you record the signals, then it's common for someone to go and do something to them, to mix them together, change their level, maybe add some effects to it to make it sound better, those kinds of things. So here in Reaper, this one, I've got two signals recorded in there just for example purposes. The first one is stereo drums, and it starts out and it sounds like this. So pretty boring right now. And then what someone could do is load up this tool called an audio plugin. This is a pretty sophisticated example. This is one called Isotope Ozone. And it has a bunch of different parameters and knobs and processors built in so that you can do things like maybe change the sound and turn up the bass or turn down the bass. So that's just one example of it. As I said, this is a pretty sophisticated one. There's lots of different knobs and sliders and menus and things to search through. This is a commercial product. It costs several $100s to purchase something like this, and it takes a lot of work to create. There are software developers and signal processing engineers that work for this company called Isotope, and they spend, I don't know, hundreds of hours, weeks, maybe months, maybe years, even to develop a piece of software like this that then someone can work with in the studio. So it takes a lot of time to develop. You'll also see here, I'll point out, just so that we can compare it to what I'm going to be working on, this one has a pretty slick looking interface. It has lots of cool colors, nice way to interact with all the different things. Even that in and of itself is a complicated thing to have to program. Somebody has to write all the code, all the instructions to the computer to say, well, when someone clicks the mouse on this thing, then that has to do something, and that has to turn the bass down, or it has to turn the bass up, or it has to do all these different kinds of things. So it looks pretty simple, and that's intentional to make it intuitive, but in reality, it takes a lot of work to do. What I'm going to be showing you is a process that can be used to prototype and create kind of demo plugins, simple plugins that can be used to test the functionality of these things. As I said, it takes a long time for these pieces of software to be developed, and it's common for there to be multiple stages of development, where initially someone is just trying to figure out, can they get this equalizer to turn the bass up on a signal, without even having to worry about this whole interface and all this fancy stuff and colors and those sorts of things. So someone might spend some time just developing the prototype of how it's going to work and at the company, and then they might hand it off to somebody else in the company to take it over and say, all right, now I'm going to take your initial code that you created and I'm going to put a fancy looking skin on the front of it, and it will look nice and do all that extra work. So what I'm going to be demonstrating is just that initial stage of how can you get something that you could load up in a digital audio workstation like Reaper and be able to interact with it and have it process the signal and do something with it. And so the purpose of this, the company MATLAB, or MathWorks, that has this software called MATLAB, that they created this, there was a lot of users of MATLAB, people that programmed in MATLAB, and they've been asking the company for a long time, hey, we start out and we prototype all our signal processing, the effects that we want to create. We'll prototype those in MATLAB, but then we need to port that code over. We need to take that code and turn it into another programming language. You probably have heard of something like C++. That's a programming language that's used a lot of times for creating these fancy audio plugins. So you usually take the step of writing your code initially in MATLAB, and then when that works and that functions correctly, it would then be turned over to somebody else to turn it into C++ code for this fancy commercial product. And so this company MathWorks, they come up with kind of a step in between where you could take your MATLAB code that's written, that's pretty relatively easy to work with, and just automatically turn that into a plugin that you can load in a DAW, digital audio workstation. So it doesn't look very sophisticated or anything like that, but it at least functions. And so if you have your own creative idea about, I want to create a plugin, or I want to do this to the signals that I've recorded, the sounds that I've recorded, this is a relatively simple way, believe it or not, to do just that. And what I'm going to be demonstrating with MATLAB, I'll pull the software up right here, is they have these extra things called toolboxes that are added on to the software. And what I'm going to be demonstrating relies on this special toolbox with MATLAB called the Audio System Toolbox. And it's something that if you wanted to do this, you'd have to have MATLAB, which is basically a fancy graphing calculator that can do all that kind of stuff, plus a bunch more stuff. And then there's these other toolboxes that go along with it. And it relies on this one right here called the Audio System Toolbox. That one's required. So this is MATLAB. This is where I'm going to be giving instructions to the computer to do some task, and it will then create this VST plugin for me to be able to use in Reaper to do this different tasks. So what I'm going to do is go through several different common audio effects, like just getting the signal to go through and change its amplitude. And then after that, I'm going to add some distortion to it and create a plugin that can add distortion to this guitar and the drums that I have. And depending on the amount of time, after that, I might demonstrate something called a stereo widener, or something that can change the stereo image to make the drums sound bigger or larger than life, or you can make them sound narrow, that kind of thing. And then I've got several more planned at least, including like a tremolo effect. If you've heard of this, amplitude modulation, it will make the amplitude sound like it's fluctuating. Pretty cool effect. And then also an equalizer, a filter, that will turn down the high frequencies. So let's see what we can get through. So here's where I'm going to be putting the instructions in to tell the computer what to do. And the first one I'm going to do is just what's called a stereo wire. What this means is we just want to get audio from the DAW, our digital audio workstation. We want to get it through our plugin and out the other end of the plugin. So it's just making sure we can get something to go through. That's the first thing. As soon as we can get sound to go through our plugin, then we can figure out how we want to change it. So the instruction that I'm going to give it is to create something called a class. The purpose of this demonstration isn't to teach you necessarily about all these sophisticated things with programming, but just to show you some instructions and how easy it is to do these things. So this is going to be something called a stereo wire. And I'm going to do this thing called inheritance, where I'm going to inherit this thing that's the audio plugin class of MATLAB. It's part of the Audio System Toolbox. So because I'm doing that, now I can take advantage of all these things built into the Audio System Toolbox. Okay, so the next step is to program in here that we need to bring the audio in and then send the audio out. And this is going to be a process. This is a special function that is built in. That's a function is something that does a task in our programming. So a function that's going to get our output signal by doing this process. So here, the way to understand this is we're going to bring the input signal into our plugin so that we can process it and do whatever we want to it. And then we're also going to have all the attributes. This thing right here that says plugin, this is going to be where we have things like knobs and sliders and objects and things that we can adjust. So if we want to turn something up or we can turn something down, all those things are going to be associated with this thing called variable of our plugin. Right there. So this one's pretty easy. What do we want to have happen? We want to have our output to get assigned or be given our input signal, so that our audio is going to come in and we're going to assign it and give it to our output. So we'll assume that the audio coming in is a stereo signal, and then we're going to pass that over to the output. And that's all it takes to build a plugin in MATLAB. Now it doesn't do a whole lot, but it will at least pass audio. So just to go through some of those steps, I'll go ahead and build this and then pull it up in my digital audio workstation. And just to prove that it is actually working, what I'm going to do here is turn the amplitude of the signal down. That way I can I can show you that the plugin is actually engaged in passing the audio through. So I'm going to turn it down by 18 dB, which means to just multiply it by a small number. When you multiply a number by a signal like this one, it's going to turn the amplitude of those signals down by whatever that is. So multiplication, it's just a number multiplied by a bunch of other numbers to process the signal. All right, so then there are some steps to actually turning this into a plugin. And the first one is to, I guess I'm going to run this. At least one end is missing. Oh yes. Okay. So here, first thing I'm going to do is what's called validate the plugin. And this is for the stereo wire. And then the nice thing about MATLAB is it does a bunch of all this stuff for me to test things out and see if it is okay for working with audio. And great, we're ready to generate the plugin now. So I can type in generate audio plugin for the stereo wire. And what just happened is it built this new thing that I'll go out on my hard drive and find that's called the plugin. And I just need to put it in the right folder. I wasn't thinking ahead of time about making sure I had all the folders up here. But this is the file that just got created. It's a VST. And so I just need to make sure that my digital audio workstation can find this VST so that it will be able to load it. So I just need to go find where all my plugins are on my computer and find the VST folder and just make sure that it's in the right place. Okay, so I think I'm going to have to close out of Reaper and reopen it so it will find the plugin. Okay, so I'm going to add VST. And I call this one the stereo wire. Okay, so believe it or not, this is our plugin, right? I haven't put any objects on there like sliders or things like that. That'll come next. But it should be the case. If I turn it on and off, it should do something to the signal. Right? Listen to how loud it is right now. And I said the purpose of the plugin was just to turn the amplitude down. So that's the very basics of being able to get something that works. So I'll go back to MATLAB now, and I'll make this a little bit more interesting. I'm going to make a new plugin that is going to have a fader on it. So right, usually an audio engineer wants to interact with an object that you move this fader around and it turns things down and it turns things up. So I can copy a lot of this stuff to make a new plugin, but this one's going to be called a gain fader. Okay, the new thing that we need to do is we need to have this variable or a thing that's going to keep track of the level that we want the audio to be changed by. So this is where I'm going to create something called a property. And I keep all the properties underneath this menu right here. And now I'm going to call my property the gain fader. And for now, I'm going to make it 1. And then I need to tell MATLAB that there's going to be this thing, the actual fader itself, that needs to be on the screen, and tell it, all right, what's the lowest value it can take? What's the highest value it can take? Right? This is what I'm trying to recreate is this kind of thing where we have, what's a good example? Like this one, digital. You have something like this where you can move the fader around and it has some minimum value like 0 and it has some maximum value like 100. and then you can move it around and set it to be things in between. So that's the type of thing that I'm going to put in there. So this is a different type of property. That we don't want someone to be able to necessarily change. This is a lot of things to type in. I might save time and just copy this over from stuff I created ahead of time, rather than forcing you all to have me forcing you all to watch me type it in. But it's pretty boilerplate stuff if I were to try to manipulate this and use it for other things. So basically we're telling our programming language that we want to have something displayed on our interface. The interface is what everyone's going to see and be able to interact with. And then from there we have a parameter. We have a slider, we have this fader that I'm going to use, and it's going to be adjusting this thing called gain fader up there, and it's going to show on the screen something that's called gain. And right now it doesn't do things on the decibel scale, so let me take that out. We'll add that in next. But we'll just have it go from 0 to 1. So 0, if you multiply anything by 0, the result is 0. So this is going to take our signal, it's a bunch of numbers, and then set them all to 0, which just means silence. If you multiply a signal by 1, then that's just going to let the signal go through. You multiply any number by 1, it just is the same thing. Alright, so we've got the essentials in there. I need to save this as gain fader in the demos one. Okay, let me run that.
I think you want to swap out that 0.125.
Oh yes, thank you. So we also need to adjust down here that we don't want to just put in a number. We want this to be our variable that can be adjusted. So the way to put this in is this is a parameter that belongs in this thing called the plugin. So I need to put in here plugin dot gain fader. Now anytime I change the value of gain fader using this slider, then it will adjust the level of the signal here. So should be able to build this one quickly again. Interesting. Let me restart MATLAB. Okay, so first step, I'm going to validate the gain fader. And then generate the gain fader. Usually takes a second, and now we're done. We've got our VST that was just built. I just need to put it in the right folder and get Reaper to show it. This is the one I just built. Again, not too terribly exciting, but we have this new thing, a slider. That I can adjust. So now I can turn the amplitude down, I can turn the amplitude up. all happening in real time there. So that's how to not only just change the amplitude, but then also add an object on the screen to change the amplitude. Using this same plugin example, what I'm going to demonstrate is another aspect of the Audio System Toolbox that allows you to just, inside of MATLAB, inside of it right here, you can do some of the testing without having to go into Reaper. Now, it's going to do the same exact thing, but it speeds up the process even more of just testing it out. So there's something called the Audio Test Bench that I can use to host this gain fader. So here it is. I didn't even have to go over to Reaper, and I can play around with it. So I could go in here and select some audio file on my computer that I could load into MATLAB this way. It pops up in a second. And I could browse and find some sound file on my computer. There's a bunch that came with the toolbox, and so I'll just use this one and play it back. And be able to interact with it in the same way I was doing in my DAW. So change the volume of it this way. That's the Audio Test Bench. Another really helpful thing about the toolbox. So one of the things that I was showing before is that usually this type of fader on a plugin is on a different scale. So on something called the Decibel Scale. This is where you maybe have seen this on like a console that you've used, or in some of the software, where it will list out that this is the Decibel Scale. So what you can do here, just with using some code, is we could take that fader and turn it into a different scale and be able to work with it. So the unity gain on the decibel scale is 0. So I'm going to set it now to be a different scale, minus 48 to plus 12, and have it put a label on there that will say that this is on the dB scale. And then I need to calculate a linear amplitude from this. All right, so now we'll have a different scale. It will go from minus 48 to 12 instead of from 0 to 1. And I can just pull that up again in our audio test bench and be able to see that there. So now we've got this gain in decibels that shows up here, and it's at unity gain to begin with. I should be able to play this again. And now we have a slider that behaves a lot like what a musician or audio engineer is used to interacting with, where when you turn something down by 6 dB, that's the same as decreasing the amplitude by a factor of 2. Or we can turn it up. So that's the basics of the gain fader that I wanted to show. The next thing that I wanted to do is show you a different audio effect. So instead of just changing the amplitude, let's do something more interesting to our signal. Let's distort it. I know that I'm going pretty quickly over some of these effects and things. I will make a shameless plug that the actual processing and things that I'm covering up here, I wrote a textbook last year with the Audio Engineering Society, and all the signal processing and things that I'm going to be demonstrating up here can be found in the book. And if you're a Belmont student, you could take classes and learn about all this stuff too. So don't get too freaked out by all this crazy stuff that we're doing. You know, it just takes time to learn about some of those things if you're interested. But but if you are, I'd be happy to talk with you about stuff that you could get involved in. Okay, so let's make another plugin. So see how quickly we can just change things over to be a distortion plugin, just by modifying the stuff that we've done. So this will be distortion. And in this case, we're going to create some drive amount, right? If you all have used distortion before, maybe a guitar pedal or things like that, there's usually a knob that you adjust to turn up the drive or turn down the drive. That controls your amount of distortion. So we just need to update some of the things on here, like to say that we're going to be manipulating distortion now. We're manipulating drive parameter. That can be the same. And we'll make our scale go from 1 to 10. Or you can make your drive go to 11 if you so choose. All right, so we just need to process our input signal now in a different way. So let me make some space for this. This is going to be a common distortion algorithm that uses a trig function. So y'all remember trigonometry? There are lots of cool stuff, lots of cool things that you can use from your trigonometry class to do fun stuff with audio. And it's just going to be taking these numbers that are part of our signal and running them through a trig function, and then, believe it or not, that creates distortion. Okay, so this will be our function for it, 2 divided by pi. Remember what pi is, and then we have the arctangent function, and we'll have our drive, so that's plugin dot drive, and that gets multiplied by our input signal. And now we have distortion. We want the drive to maybe start at 5. So not all the way up, not all the way down, just a little bit of distortion, part of the way in between. So think of this as a knob that you would have like on a guitar pedal, on a guitar amp, where you're turning up the amount of the distortion. This should be multiplied. Okay, so I'll just jump back into our test bench with our distortion, and now this thing is going to make there be more or less distortion. Maybe I'll find a different sound file to use that might be interesting. How about rock drums? So less distortion, more the original recording. I'm trying to really smash it. So that's a basic distortion effect. I also wanted to demonstrate something cool about the audio test bench. If you really wanted to get into analyzing how some of these plugins work that you're creating, which is a common thing for a developer, signal processing engineer want to be able to do, there are some cool features that are built in as part of this. So what I'm going to do is switch this over to another type of signal. This is something called a sine wave. So maybe you all have heard of sine waves before, maybe not, depending on where you're at so far in the semester. But this is a signal that has a single frequency. So you're just hearing one frequency at a time until we start to distort it, and then you're going to get a bunch of other frequencies that go along with it. So let's listen temporarily, and I'll turn it off because it could get annoying, to what this would sound like to distort a sine wave. So this is what is happening to the signal when you actually distort it. Let me keep it going, but then mute it here. So we have the signal going. There are these cool graphs that are part of the toolbox to use. This is one called a scope, where we can look at the waveform of our signal that will pop up here. And we can see what the result is when we start to modify it. So I'll zoom in. We can look at just a few cycles of our sine wave, like this. It should slow down and catch up here in a second. So I'll try to put these things side by side. And then as we have the original signal is in yellow, it might be sort of hard to see in the blue. But then as I distort it, it's going to shape the blue signal in a new way to change it. And it's like, well, what change has that happened to the signal? There's different ways to understand it. One of the things to look at the distortion is to look at the other harmonics that are created. Harmonics are other frequencies that end up occurring with the signal. So a sine wave, it starts out as a single frequency, and then as you distort it, there are these other harmonics. Maybe you've heard of overtones with music. So our distortion that we're adding in here is taking this first harmonic and then adding in a bunch of these other ones above it. And so as we adjust the drive, the distortion amount, it's going to change the level of those harmonics. You can see that they're starting to go down, decreasing the amplitude of those harmonics with our distortion. So that's a common way that engineers will look at the amount of distortion that's occurring, is the amplitude of those harmonics. To take it even a step further, cool thing that's built into the toolbox is it has this common analysis called total harmonic distortion. THD is the way that distortion is usually measured. And MATLAB will do all this for you. So this is a really, really nice feature to be able to do. It has a distortion measurement, and it will detect the harmonics for me. So if I switch this over to look at the output channel, down here it will say that I have 23% total harmonic distortion. And as I move this around, it will end up with less harmonic distortion or more harmonic distortion. So besides just the toolbox being a useful thing for someone to quickly and easily be able to mock up a basic plugin like this that has a parameter on it, there's also all these other analysis tools that can be used to verify and see whether your plugin is doing what you think it's supposed to be doing. So in this case, we're distorting it. We've got a bunch of these harmonics in our output signal, and we can see, well, what's the level of these harmonics for the amount of distortion that we're adding. Does that make sense? All right, let's look at a few more plugins, and maybe I'll just pull up ones that I've already created rather than writing out the code, and we can talk through what's going to take place with this one. So the one that I'll pull up next is something called a stereo Widener, or sometimes in plugins, I'll pull it up here, it's called an imager. So this is one that's found in this commercial software. And how does it work? When an engineer wants to take this stereo recording of drums, he or she might want to make the drums sound wider or also narrower. How wide do you want it to be? With rock drums or something like that, you might say, I want these things to sound larger than life. And so you might want to add some effect like this in Imager to do just that. I'm not sure how well it's going to translate on this stereo system, depending on where you're sitting in the room, but I'll at least give it a shot. The things to listen for is the room sound that you hear when I play it back. Now, how much of the room sound do you hear, or does it sound close, or does it sound far away? I think it's processing it. So this should be more of the room sound. and this should sound closer. You can see it's affecting it on the stereo width meter over here. I promise you the one that I make will sound even more exaggerated than this. So that's the Widener. Alright, so this one is just another case where we want to have one parameter, a width parameter, and then I'm going to use something called mid-side processing. It's a way of taking a stereo signal, that's the left and the right speakers, and separating it out into parts that are the sounds that are in the center. Like think of the kick drum and the snare drum that are in the center of the mix, and things that are on the outside, like the room mics and the toms that are panned from one side to another. Trying to separate those into two parts. So with mid-side processing, we separate it into those parts, and then we turn the amplitude of the things that are on the side. We're going to turn those up while we turn things that are in the center down, or vice versa. That's what our slider is going to do. So let me go ahead and pull this one up. I make sure I'm in the right folder. I think I'm in the wrong folder. Stereo width. Thank you. Okay, so we need a stereo something. Let's try some drums. Okay. This is wider and this is narrower. So this one you'll just hear more of the close mics on the drums. It'll sound like the snare drum, the kick drum are much closer to you and not as large. So do that again. So this is narrow and large. So creative effect, one that you could use to just take the original recording and enhance it in a subtle way. So that's the stereo width. I've got some other ones that I can quickly demonstrate. Some more things here. I'll pull up something that acts like an equalizer or a filter. This is what's called a low-pass filter. It's going to reduce the amplitude of low frequencies it'll reduce the amplitude of high frequencies and let the low frequencies pass through. So again, almost all the same kinds of stuff I was doing before, except the difference is now we have a frequency, that's our parameter that we're going to want to adjust, and then we have a Q, a resonance sort of control. More things just to add on to it, more sophisticated. If you're really interested in some of this code, I'd be happy to make it available to those of you that are familiar with MATLAB. Let me demonstrate another cool thing about the audio test bench of the low pass. So now I've got more parameters to work with. The frequency and then the Q, the resonance. So let me play this one back and show you what it sounds like. Sounds more muffled in this case. You can also make it sound more resonant. So a good way to understand this one is to switch the type over to noise. Might sound annoying for a second, but I promise I will take it off. Depending on what styles of music you all like to listen to, you maybe have heard that a common thing to add to music now a sweep or something like that to build up the intensity of a part of a song would be a sweep like that, where you have some resonance that then accentuates the noise that's occurring. So that's obnoxious to listen to, but fun to look at. So I'll pull up this tool again for looking at it, and now we can see for these different frequencies what's occurring. So we have the blue part. This is showing frequency and amplitude. And so right now we have this resonance happening at the higher frequencies like this, maybe just so we can associate what we're looking at with the sound. So these are the common types of parameters you'd find on an equalizer plugin, or maybe on like a synthesizer. If anyone's into working with a synthesizer, you have this Q, this resonance that you turn up and gives the synthesizer its sound. This is acting as the low-pass filter, where the noise down here at low frequencies is going through. We have our resonance that's happening over here that we can turn up and down, and then it's going to reduce the amplitude of these higher frequencies. Some nice parameters for adjusting some of these things, if I remember where they are, that are nice for trace options, averages, 20. It's going to do some smoothing on it now so that it's not as sporadic. So another cool thing about the toolbox to have all these different kinds of controls built right in for testing some of these things out. So what I think I'm going to do is just call it quits there. This was a demonstration of the Audio System Toolbox built into MATLAB. A quick and easy way for someone to be able to create their own plugin. And then you can build it, load it in your digital audio workstation, load it in Reaper or GarageBand if it can host VSTs. And then also some cool stuff about being able to test it right inside of MATLAB. So thanks for hanging out. We meet once a month, as I said before. Please come back again. It's a great place to learn more about opportunities that there are in audio engineering and things associated with computer programming. I guess we'll take a few questions before we stop.
I just need to know, what is your name?
My name is Eric Tarr, T-A-R-R. Other questions? Questions, thoughts?
What about audio units?
Audio units. So, this will only build VSTs. I'm not sure if MATLAB is going to, or MathWorks is going to add AUs in the future. It definitely doesn't do AAX plugins, but the VST SDK is built into the toolbox. I would say most people that are working in audio work on a Mac, but most people that program in MATLAB are not audio people. And so they don't necessarily cater this for Mac people as much as they're like, okay, most of our user base is on Windows, so we'll just put in VSTs. I don't know their future plans for doing it, though. There was one more question, or any other questions before we stop? All right, if anyone is interested in presenting next month, please see me. I'd love to talk with you about doing that. Have a good rest of your evening.